Level of detail expressions, introduction. Level of detail expressions were introduced to give us control of how aggregations behave when added to a view. In this section, we are going to explore level of detail expressions, and in the next section, we will further cement our knowledge by going through several exercises together. So, the key takeaway here is that level of detail expressions is fantastic. To understand them, to be able to leverage them in your data visualization, will open the door to so many new things. So, I hope you're excited. Let's move on to the next lesson. Level of detail expressions, understanding aggregations. Before we dive in to level of detail expressions, we need a quick recap as to how Tableau aggregates your data. In essence, how Tableau builds your first level of detail, what we call the view level of detail. So to understand this, let's quickly go into Tableau Desktop. With Tableau Desktop open, what I want us to do is go to Microsoft Excel. Let's open our sample superstore. Let's take orders in. Nice and simple. Let's go to our sheet. Now, this is the interesting thing that we have to consider. If we build a visualization, let's say take orders into columns. Let's take subcategory into rows. Now, if we take cells and bring that onto our visualization, the cells is currently being aggregated based on your subcategory and your year. Each of these individual columns. This is actually a level of detail because we are aggregating or showing the sum of cells based on an aggregation, based on the dimensions in our view. This is what we call the first level of detail or the view level of detail. So I want you to understand that is that every time we aggregate based on our dimensions. Now, this is where it becomes interesting. Level of detail expressions allows you to modify that. It allows you to calculate your sum of cells, for example, not just based, in this case, year and subcategory, but other dimensions as well. This is why it becomes very powerful. The main thing I want you to take away from this lesson is that all of our fields, all of our data, when we add data to Tableau, when we ask Tableau to visualize our data, Tableau would always try to aggregate our data up. You do have an option here where you can choose not to aggregate measures, but that's for another day. However, in our case, I want you to get ready and move on to the next lesson. Level of detail expressions, scoping keywords. When Tableau introduced level of detail expressions, they wanted to give the end users the ability to define their own scope, define how Tableau aggregates your data, and therefore they added 3 scoping keywords: fixed, include, and exclude, as well as a new syntax. In the next few lessons, we are going to see what fixed, include, and exclude does, what's the functionality behind all 3, as well as the following syntax. Again, we are going to explore this in great depth. The key behind this is that we are using curly brackets. That lets us know that, or lets Tableau know that this is a level of detail expression. We have a scoping keyword, either fix, include, or exclude. We have our list of dimensions, and we have an aggregation. So something along these lines. What we're telling Tableau right now is that this calculated field is going to represent the sum of cells fixed at a country level. And again, we're going to cover these keywords. What does fixed mean? It can be replaced by include and exclude. We are going to tackle this in the following lessons, but the key is, as you can see, it's not too hard to write such expressions. So hopefully you're ready. We're going to go through what each of these means, but I'll see you in the next lesson. Level of detail expressions, fixed level of detail expressions. The fixed scoping keyword allows us to define what dimensions, what dimensionality will be used in our calculated fields. Therefore, in essence, this makes our calculation independent of what dimensions are in the view's level of detail. This is what it looks like. We have our curly brackets that symbolizes a level of detail expression. We have our scoping keyword, which is fixed. We have our dimension, which is region. Then we have our aggregation, which is sum of cells. However, let's explore this in Tableau. So the first thing I want us to do is go to Microsoft Excel. Let's load in our sample superstore data source. From this, we are going to create our fixed level of detail expression. So let's take orders, let's drop that in. Let's go to sheet 1. And let's start off by building a very simple data visualization. Let's take regions and drop that into rows. Let's take order date and drop that into columns. Nice and simple. And now let's double click cells to bring that into a data visualization. We're aggregating sum of cells based on region and based on year. This looks pretty standard, pretty simple so far. But what happens if I want to create a level of detail expression just to show the cells by region? So in essence, let's create a new calculated field and let's call this region cells. We are going to create our first level of detail expression, open curly brackets, fixed. We are going to put our dimension as region and then sum of cells. So that is nice and simple. We are fixing this. That means that we are creating a calculation for sum of cells for the region only, regardless of order date or region. But the key is let's use this. Let's click apply. Let's leave this window open. Let's double click on cells, regional cells, and you can see you've added it to your visualization. As you can see here, your regional cells now has that value. You can see regardless of if we have year or quarter, that value is still the value of the sum of cells for the whole region. This is what we mean by when we say by fixing, you are setting your aggregation to be at a certain level or dimensionality, regardless of what is in the view. So what I want you to do is have a play with this. Try adding different dimensions to the fixed dimensionality. For example, replace that region with something else, or change your aggregation type. The key behind this is that it's quite a simple function. There's a lot of taboo around the complexity of LODs, but it's as simple as that. You are now manually setting the exact dimensions that you want to be included in your aggregation when you're using fixed level of expression. So enjoy, explore, and in the next lesson we are going to look at include. Level of detail expressions. The include level of detail expression. The include scoping keyword allows us to include additional dimensions to our aggregated calculations. In essence, we are adding dimensions to those that are in the view's level of detail. and this is what it looks like. So sometimes you might want to build an aggregation. You wish that you had the ability to include some dimensions in there, even though you don't want to display it. To take into account, but not display. And there is where include becomes very useful. So let's go into Tableau and explore this. Let's click on Microsoft Excel. Let's load in your Superstore data source. And once ready, let's take orders and drop it in to the query panel. And let's go to our sheet. Again, we are going to build a very simple data visualization just to highlight the power of the include LOD. Let's take order date and drop it into columns. Let's take region again and let's drop that into rows. At the same time, I want us to take category and drop that into rows as well. Let's double click cells, but this is where include becomes very useful. If you wanted the average cells, for example, you can see this is quite easy to do in Tableau. However, if you look at the following values, imagine if we wanted to average the average per category, i.e. average and average. We can easily do that. However, we might not want to show the category. Let's see, let me just create a LOD expression with you. We'll create it together and then we can see what we mean here. But the key is that if I take away category, you get the average of everything within your data set. However, I want to average for each of the categories first and then average them afterwards. So let's see this in action. Let's put category back. Let's create our include LOD expression. So we're going to say average. We're going to say cells per category. So not the total average of all items, but per category. Curly bracket to open. Let's put include. Now this is the interesting thing. We are going to include category for now. And we are going to make the aggregation the average of cells. Nice and simple. And now let's click apply. Let's double click this to include this in our data visualization. As you can see, the numbers are exactly the same. There's no real difference because we're including category. Category is already in the data visualization, so it's already included. But what happens if we remove category? Because we don't want to see it. That's our data visualization. Let me just make sure we average the LOD that we created. As you can see, the numbers are slightly different now. The reason being is that your average cell is not taking into account the category. It's just doing an average of everything within your database. What our level of detail expression is doing is that we are taking the average of each category and then doing the average afterwards. So as you can see, an average of an average, i.e. we're including this data, this dimension that is not in our view. It's not in our tooltip. Detail is nowhere to be found apart from in the data. We are taking that into account into our data visualization, into our view, and hence we are including. So what I want you to do is explore this, change the dimension, try to get your head around how include works and how you can use it in your own data visualizations. Once you're happy, let's move to the next lesson. Level of detail expressions. The exclude level of detail. The exclude scoping keyword allows us to define what dimensions are to be excluded when we aggregate our data. In essence, we are removing dimensions from those that are defined in the view's level of detail. And this is what it looks like. It is the same syntax apart from exclude as your scoping keyword. So let's explore this by looking at Tableau. So the first thing I want us to do is go to Microsoft Excel and let's load in our sample superstore data source. And as always, let's bring our orders. By the way, as you're doing this course, why not try to actually apply your own data sources? So to build some LODs over your own data source, just to have fun and just to explore this in your own data source, in your own organization. Let's go to Sheet. Now again, to demonstrate the exclude scoping keyword, let's build a very simple data visualization. Let's take order date, let's drop that into columns. Let's take region and let's drop that into rows. And let's take category and drop that into rows also. Let's double click cells to add that to our visualization, and this is quite a simple view of data. We have region, category, order date, and we have the sum of cells. So what happens if we want to show the sum of cells and not actually include the category? If we just want to show the sum of cells for region, yes, we can use the table calculation. However, let's do this using our LOD. So let's create a new calculated field. Let's call this cells excluding category. So from here, let's start our LOD expression with the curly open bracket, exclude. We're going to say we want to exclude category. And let's put our aggregation, sum of cells, and let's have a look at what that shows when we add that to our view. Let's click apply, let's keep the box open. Let's double click this. So as you can see, the sum of cells is now the sum for the entire year, not taking into account the category. So if we add up the following, that will give us 103, and that is exactly what we see there. So in essence, even though Tableau is showing the category, even though Tableau is displaying this information, we can actually remove it from our calculation. And this is a very simple explanation of what the exclude does. So to summarize, just very briefly, we have fixed, which allows us to define exactly what dimensions are in play. We have the include to say, great, we have 5 dimensions in the view, add the following also in terms of how you aggregate data. And then we have the exclude that says, you have 5 dimensions. I want you to always try to remove the following list. In this case, category. So have a play with this, explore this yourself, because that's the only way you'll truly learn and understand how you can apply this. Try to apply this to your own data set within your organization. And soon in the next section, we are going to go through several exercises to hopefully reinforce your understanding of LODs. Level of detail expressions, nested level of detail expressions. The results of a level of detail expression can be nested. This nesting can happen in a single calculated field or by referencing multiple level of detail expressions. Now typically there are performance considerations. LODs within LODs within LODs can have some performance impact, so do be careful. I also prefer to separate my LOD expressions into different calculated fields to make my life a bit simpler when it comes to reading and understanding, and also that allows me to explore each LOD in isolation before combining. But you can create a single calculated field with the following. As you can see, you have your exclude. We exclude an order date from our aggregation, and then we're doing an average of something. That something typically has been an aggregation from a field. However, we have now included a LOD in there, and we can keep on going. But we can include, exclude, include. The key thing here is to bear in mind the scope of each of the individual LOD expressions. It does become very complicated, and to be quite fair, there's not a huge amount of use cases where you'll need to do this, but just be very careful if you do. Typically in my day-to-day, I very rarely, if ever, use nested LOD expressions. But the main thing from your learning perspective is to understand they exist, and the other thing is to drive your exploration and your creativity. At this point, you now have seen how we can write fixed level of detail expressions, include as well as exclude. So what I want you to do now is try to work with multiple versions and nest them together. So explore this concept of actually nesting your LOD expressions. Level of detail expressions, understanding level of detail filtering. You can use your level of detail expressions to filter your dashboards. That's perfectly fine. One of the key things to understand is where they sit in the filtering order. So what filters are applied first and what are applied afterwards. The key thing is that level of detail expressions have different filtering orders depending on the type of expression that we have written. For example, if we use fixed, it will be slightly different order from the others. Easiest way to do this is to visualize it. So the first two filters in our filtering order is extract data source, then we have our context filters, and then we have our first LOD filter. So we would apply the fix first because the fix defines the exact objects that we are dealing with. After which we can have our dimension filters, so this is all your dimensions that you're throwing into your filter pane. After which we then have include and exclude. Remember, these expressions are dependent on your dimensions, whatever dimensions values you may have. After which we are going to look at our measure filters, and finally, as we've seen in the previous section, table calculation filters are last. What I would suggest you doing is trying to use LOD expressions in filters to see what happens, to explore this functionality. But apart from that, the filters are used in the same way as any other filters. There's just a slight difference in ordering that you should be aware of. So, explore, have a play with this, and I'll see you in the next lesson. Level of detail expressions, understanding level of detail limitations. When using level of detail expressions, there are several things to be aware of, and this will be make or break for you. Level of detail expressions that reference floating point measures can behave unreliably, so just do bear that in mind. Personally, I've not seen this or experienced this, but do bear this in mind. Level of detail expressions are not shown in the data source page, so when you're looking at your data source page and you're exploring your data, LOD expressions will not show up there. When referencing a parameter in the dimensionality declaration, i.e. straight after the scoping keyword, you can put a parameter there. Always use the parameter name and not the value. And this for me is the biggest limitation, and something that always comes back to haunt me, is if you're doing data blending, the linking field from the primary data source must be in the view before you could use a level of detail expression from the secondary data source. A lot of times when you're doing blending, you will find creating LOD expressions potentially painful. Typically, this is when I'll start thinking about table calculations, or in my world, trying to avoid data blending where possible, because you do find a lot of these limitations. But the key thing is to be aware that these limitations exist, to plan for them, and to be honest, when you find functionality that is not what you're expecting, fall back on this and see if this might be the reason.